This powerful runtime can become a personal assistant that behaves less like a chatbot and more like a real operator, executing tasks, managing workflows, and reporting back to you through channels like WhatsApp, Telegram, or Discord. With the right structure and instructions, it can take on multiple roles at once: monitoring systems, organizing information, drafting communication, filtering noise, and triggering actions without waiting for you to open a browser tab. In this video, I'm going to walk you through everything, from installing and structuring OpenClaw properly, to understanding how it connects with leading AI models, how persistent storage actually works, how to think about security the right way, and finally, 10 real-world use cases that I've personally been running with it, all this while ensuring you are 100% in control over your data. If you want the structured version of everything we cover, you can download the full PDF guide using the link in the description. Now let's get started. Before we even touch installation or configuration, I need you to shift how you think about OpenClaw, because if you approach it like just another AI tool you can open in a browser and experiment with for 10 minutes, you're going to completely miss the point of what makes it powerful. OpenClaw is fundamentally different because it's a long-lived gateway process that stays alive in the background, maintains connections to your messaging platforms, keeps its memory on disk instead of inside a temporary chat window, and routes real inputs into real tool execution on your system. And that single shift, from AI as a tab to AI as a runtime, changes how you should think about everything that follows. Because once something is designed to be always on, it stops being a tool you occasionally use and starts becoming infrastructure that works continuously on your behalf. And infrastructure has different rules. It needs stability, it needs uptime, it needs a proper environment. That's the mindset we're bringing into this video from the very beginning. Here's the mental model I want you to lock in before we go any deeper, because if you understand this properly, everything else becomes intuitive. OpenClaw is essentially a router between communication and execution. Messages come in from channels like WhatsApp, Telegram, Discord, or even from local CLI commands and scripts. The gateway process receives those messages and routes them to the agent runtime. Now, the agent isn't some mysterious black box. It operates based on configuration, workspace files, persistent memory stored on disk, and the skills you've enabled. Those components define what it knows, what it remembers, and what it is allowed to do. That's why OpenClaw feels powerful. It bridges the gap between conversation and execution, and it does it continuously, not just when you're actively watching. And the moment execution enters the picture, environment design starts to matter a lot more than people expect. If there's one core distinction I want you to walk away with, it's this. OpenClaw is not about writing better prompts. It's about building continuity. When you use AI in a traditional way, every interaction is isolated. There's no persistent state beyond the session, no guaranteed uptime, no real boundaries around what can or cannot be touched. Running OpenClaw is different because it introduces persistence at every level. Persistent connections to messaging platforms, persistent workspace memory that survives reboots, repeatable automations that execute on schedule, defined system boundaries that determine what the agent can access. And because OpenClaw can execute real tools, security is no longer a nice-to-have discussion. It becomes part of the architecture from day one. Before we install anything, we need to decide where OpenClaw is actually going to live, because that decision affects everything that comes after it. Running locally gives you full visibility into what's happening under the hood. You see the workspace, the configuration files, the onboarding process, and you learn how the runtime behaves. It's a great environment for understanding the system deeply. But there's an important trade-off. Your local machine is not a dedicated runtime environment. It contains your projects, your personal files, your credentials, and everything else you use daily. The moment you enable tools or persistent automations, you're mixing infrastructure with your everyday system. Now here's where things get interesting. Modern VPS providers make deployment extremely simple. In fact, with the environment I recommend, you can deploy OpenClaw with a one-click setup, manage containers through a clean web interface, and have a fully isolated runtime running in minutes. No manual Docker orchestration, no babysitting processes, it just runs. Now let's talk about the actual installation process, because this is where the experience starts to differ significantly depending on where you deploy. If you're running locally, you'll need Node version 22 or higher, then install OpenClaw globally and run onboarding with the daemon flag. That daemon flag installs the gateway as a background service, meaning it starts automatically on boot and keeps running without you keeping a terminal open. After that, you verify status, check health, and run security audits to make sure everything is configured correctly. It's not complicated, but it does require you to manage the environment properly. Now compare that to deploying on a VPS designed for containerized workloads. In that case, you're looking at a one-click OpenClaw setup through a web interface. The container is provisioned, the runtime is isolated, and it's already configured to run continuously. If you want a full walkthrough of the VPS deployment process, I've already made a dedicated video where I go step by step through the setup. You can find it linked right here on screen and in the description below. Before we go further, you need a mental model of where everything actually lives. OpenClaw stores its state inside a dedicated workspace directory. This is where your configuration files, agent definitions, skills, sessions, and long-term memory are stored. Think of this folder as the brain of your runtime. If you back this up, you preserve your agent's identity and history. If you delete it, you're essentially starting fresh. You don't need to memorize every file here. You just need to understand one thing. OpenClaw is stateful, and that state lives on disk. That's what makes it infrastructure and not just a session. Now let's clarify something important, because this is where OpenClaw starts separating itself from typical AI usage. There's a difference between what happens during runtime and what actually persists on disk. The runtime includes live sessions, active tool execution, and whatever context is currently being processed. That's temporary and it exists while the system is running. But the persistent state is what gives OpenClaw continuity. Your agent configuration, your enabled skills, your tool policies, your stored memory, your session history, all of that lives on disk and survives restarts. That's the key shift, because if you shut down your machine and start it again, your agent doesn't forget who it is. And once you understand that persistence exists, you start thinking more carefully about where that disk actually lives. Up until now, everything we've discussed lives inside the system. But OpenClaw becomes powerful the moment you connect it to the outside world. You can link messaging platforms like WhatsApp, Telegram, or Discord, and suddenly your agent is no longer something you open in a terminal, and it becomes something you talk to from anywhere. You can also trigger it through CLI commands or webhooks, which means it can integrate with other services and automation flows. What matters here is not the specific platform. It's the fact that OpenClaw maintains persistent connections to these channels and routes messages into real execution. And once your agent is reachable from outside your machine, the runtime stops being private experimentation and starts becoming something exposed to the world. That's where architecture decisions start to matter even more. Connecting OpenClaw to messaging platforms gives it access. Skills give it ability. A skill is essentially a capability module. It tells the agent how to use specific tools, how to structure actions, and how to execute defined workflows. For example, you might have an email skill that knows how to send messages through SMTP, a file system skill that can safely read and write files, or a browser skill that can navigate and extract data. Each skill expands what the agent can do. And here's the important part. Skills are modular. You don't have to give the agent everything. You decide what it's allowed to access. That's where architecture and security start intersecting, because power without boundaries is just risk. Let's start with the first real use case. Imagine that every morning at 8 a.m., without you typing anything, your OpenClaw agent wakes up, pulls data from your business, maybe revenue, usage, server load, or marketing performance. Then it compares yesterday's numbers to a rolling 7-day average, detects unusual patterns, and generates a structured summary. That summary is automatically sent to you on Telegram, and at the same time, a condensed version is stored inside the agent's memory so it can recognize trends across weeks, not just days. You didn't open a dashboard, log into anything, or write a prompt. it just ran. This is where OpenClaw shifts from being reactive to being operational. And this kind of workflow doesn't make sense if it only runs when your laptop or Mac Mini is open. It's designed to operate continuously. Here's another everyday scenario. Imagine you're scrolling and you find an interesting article, GitHub repo, research paper, or idea. Instead of bookmarking it and forgetting about it, you simply forward the link to your OpenClaw agent through Telegram. The agent extracts the content, summarizes the important parts, tags it by topic, and stores it in its long-term memory. Weeks later, you can ask something like, "What was that article about vector databases I sent you last month?" And it retrieves a structured summary instantly. You're no longer collecting bookmarks, you're building a searchable knowledge layer. And because that memory is stored on disk, it survives restarts. It grows over time and it becomes an asset. This is where persistence really starts to matter. The longer the system runs, the more valuable it becomes. But again, focus on the pattern: input, processing, storage, and retrieval. Let's say you just finished a meeting. Instead of manually reviewing notes and creating tasks, you drop the transcript or even a voice summary into your OpenClaw agent. The agent scans the content, identifies action items, detects who is responsible, infers deadlines if mentioned, and structures everything into a proper task format. It then pushes those tasks into your task manager and sends you a clean summary of what was extracted. At the same time, it stores key decisions inside memory, so that next week, when you reference that meeting again, context isn't lost. You're not rewriting notes or manually transferring tasks or relying on memory. You're converting conversations directly into structured execution. And once you depend on that workflow, even a little bit, you start realizing this system isn't something you want turning off when your laptop sleeps. The bigger idea is that OpenClaw doesn't just answer questions, it converts input into structured outcomes. That's productivity at the system level. Let's switch domains a bit. Imagine your email inbox no longer being a constant distraction. Every time a new email arrives, your OpenClaw agent classifies it. It determines whether it's urgent, informational, or ignorable. If action is required, it extracts the relevant details and can even draft a contextual reply based on previous conversations. If it's urgent, it forwards a summary to Telegram so you see it instantly. If it requires work, it creates a task automatically. And if it's just informational, it stores a short summary in memory so you can retrieve it later without rereading the whole thread. You're not manually sorting or skimming noise or reacting blindly. The system becomes your first filter. And this is the kind of workflow that makes sense only if it runs continuously. Emails don't wait for you to open a terminal. But again, focus on the system thinking, event, classification, action, persistence. That's automation at the communication layer. Now, let's move into something slightly more technical. Imagine one of your services goes down in the middle of the night. Instead of finding out hours later, your OpenClaw agent continuously monitors health endpoints, CPU usage, or log anomalies. The moment something fails, it detects the issue, checks recent logs, attempts a controlled restart, and then sends you a structured incident report explaining what happened and what it did. You wake up and see Service X restarted at 3:14, CPU spike detected, and it was recovered successful. No manual SSH or reactive scrambling. This is where OpenClaw starts acting less like an assistant and more like an operator. Keep in mind, the pattern stays consistent. Monitor, detect, act, and report. That's operational automation. Let's say you get an idea randomly during the day. Instead of writing it in a Notes app and forgetting about it, you send it directly to your OpenClaw agent through Telegram or WhatsApp. The agent takes that raw idea, expands it into a structured outline, generates talking points, suggests strong hooks, and even checks your existing memory to avoid repeating content you've already created. It then stores a clean draft inside your workspace and adds it to a content queue so you can revisit it later. You're not staring at a blank page anymore, but you're turning scattered ideas into structured assets automatically. And this is where something interesting happens. The longer the system runs, the more context it accumulates about your tone, your topics, your past work, and it becomes a personalized content engine. That only works if it's persistent. Let's switch gears again. Imagine your OpenClaw agent syncing with your financial data once per day, whether that's through an API, exported CSV, or another integration, and automatically categorizing your expenses. It detects when spending in a category exceeds your monthly average, flags unusual transactions, and generates a weekly summary showing where your money is actually going. Instead of opening banking apps and manually scanning transactions, you receive structured insights directly in Telegram. If something abnormal happens, an unexpected charge, a spike in a category, you're notified immediately. Over time, the system builds historical context, allowing it to detect patterns and trends instead of just raw numbers. You're not just tracking money, but you're building financial awareness that compounds over time. And like every other use case we've discussed, this only makes sense if the system runs consistently and retains its history. Let's look at something developers will instantly appreciate. Imagine a new pull request is opened in your repository. Instead of waiting for someone to manually review it, your OpenClaw agent automatically analyzes the diff. It checks for risky patterns, large refactors, missing tests, or violations of project conventions. It compares the changes against past code patterns stored in memory and generates structured feedback. That feedback is posted directly as a comment on GitHub, and you receive a summarized version in Telegram. You open the PR, and the first layer of review is already done. This isn't replacing human judgment, but it's accelerating it. And because the system stores patterns over time, it can adapt to your code base instead of applying generic advice. This workflow only makes sense if the runtime is continuously listening for repository events. Let's make this practical at a personal level. Every morning before you start your day, your OpenClaw agent reviews your calendar, scans your task backlog, detects overdue items, and evaluates how much realistic work can fit into the available time. Instead of you manually choosing what to focus on, it generates a structured daily plan. Your top 3 priorities, recommended time blocks, and any conflicts it detects between meetings and deep work. It can even automatically create calendar blocks to protect focus time. Over time, it observes patterns, it learns how long tasks typically take, it notices when you overload your schedule, it starts making smarter suggestions. You don't wake up to notifications, and you wake up to clarity. And this kind of workflow becomes more valuable the longer it runs, because it learns from your behavior over weeks and months. Now, let's take this one step further. Imagine your OpenClaw agent continuously monitoring sources that matter to you, whether that's industry news, job boards, competitor updates, niche forums, social media threads, or product announcements. Instead of you scrolling endlessly, the system filters content based on criteria you define. It scores relevance, detects high-value signals, and highlights only what truly matters. But it doesn't stop there. When something important appears, maybe a potential client opportunity, a relevant job listing, or a partnership signal, it can draft a response, prepare a proposal outline, or create a follow-up task automatically. You're no longer reacting randomly to information, and you're systematically scanning for opportunity. And because the system runs continuously and stores context over time, it learns what actually leads to meaningful outcomes. This is where OpenClaw stops being an assistant and starts behaving like leverage. Let's zoom out for a second. Every single use case we've gone through, whether it was business metrics, knowledge capture, task extraction, email triage, monitoring, finance tracking, or opportunity scanning, followed the exact same pattern. Something triggers the system. The agent processes context using defined logic. It executes specific tools within defined boundaries. It produces structured output, and it stores state persistently, so the system compounds over time. This is not about individual tricks, but about event-driven architecture. Once you see the pattern, you stop thinking in prompts and start thinking in systems. And systems only make sense when they're continuous. Now let's be honest for a moment. All of these workflows look powerful, but they only work if the runtime is treated seriously. If you run everything casually on a laptop that sleeps, automations stop. If you mix execution tools with your personal system without isolation, you increase risk. If you don't back up your workspace, you lose memory and history. If you don't define tool boundaries, external inputs become exposure. If you don't monitor the runtime, failures happen silently. None of this is dramatic, it's just architecture. The more you rely on the system, the more important the environment becomes. If you look at everything we've covered so far, the workflows, the persistence, the event-driven triggers, you'll notice something important. This is not designed to be opened occasionally. It's designed to run. The clean way to run OpenClaw in production is simple. Your personal devices, laptop, phone, are just control surfaces. The runtime itself lives inside an isolated VPS environment that stays online continuously, stores persistent state, and executes tools inside a controlled boundary. OpenClaw runs there as a long-lived process. Messaging channels connect to it. Workflows execute there. Your devices simply interact with it. This separation gives you uptime, isolation, and clarity. If you want to see the exact step-by-step setup for this architecture, I've already created a full deployment walkthrough. It's linked here and in the description. But whether you use my exact setup or not, the principle stays the same. If it's infrastructure, it deserves an infrastructure environment. That's the difference between experimenting and operating. At this point, you've seen what OpenClaw can actually become when it's treated as a system instead of a chatbot. You can explore locally, understand the internals, and experiment with workflows. If you want the structured configurations and examples we covered, download the infrastructure blueprint. It's available for free. OpenClaw is powerful, but the real leverage comes when it runs consistently, safely, and with intention. Build it once, then let it work. Thanks for watching and see you next time.